Hi everyone! Today we're going to be talking about piecewise functions. Our objectives for today are that students will be able to write, evaluate, and graph piecewise defined functions. Let's get started. So what exactly is a piecewise function? Well, here's the formal definition. A piecewise function is made up of two or more functions, each with its own domain. So I'll say that one more time. A piecewise function is made up of two or more functions, each with its own domain. So basically, simplified, a piecewise function is when we have two or more functions put together on the same graph, and we will graph each function separately based on the domain of that function. Alright, so make sure you've copied down this definition, and then we will move on to some examples on evaluating and graphing them. So in order to evaluate piecewise functions, here's what we need to do. So given this piecewise function, so piecewise functions will always look like this, where we say f of x, because it's a function, is equal to, and we put a brace because we have two separate functions. Our first function is x squared minus 1 if x is less than negative 2. So that is the domain of this first function. Okay, so when x is less than negative 2, this is our function. Now our second function says 5x plus 3 if x is greater than or equal to negative 2. So the domain of this second function is x is greater than or equal to negative 2. So when x is greater than or equal to negative 2, this is our function. Alright, that's how a piecewise function works. And this is what piecewise functions will look like. Alright, so if we're given this piecewise function, we want to find each value. So for example, for part A, we're saying f of negative 5. So we want to know the output of the piecewise function when our input is negative 5. So when x is negative 5, which one do we want to use? So we look at our domain. This one's saying when x is less than negative 2. This one's when it's greater than or equal to negative 2. Well, negative 5 would be less than negative 2. So we're going to use this function right here to evaluate this part of our piecewise, all right? Because when x is less than negative 2, we're going to be using x squared minus 1. And then we want to plug in negative 5 for x. Negative 5 times negative 5 gives us 25 minus 1. So f of negative 5 is 24. All right, now for part B, when f of negative 2. So when x is negative 2, which function do we want to use? Do we want to use the top one or the bottom one? Well, f of x, our x is equal to negative 2. So we're going to use this one because this domain is when x is greater than or equal to negative 2. So if x is negative 2, this is the function we're going to use. So we're going to be using the function 5x plus 3. And we want to plug in negative 2 for x. So we get negative 10 plus 3. So f of negative 2 equals negative 7. Last but not least, f of 7. So when x is 7, which one do we want to use? Well, the domain that falls in would be here because 7 is greater than or equal to negative 2. So once again, we're going to be using 5x plus 3. So we're using our 5x plus 3 function, and we're going to substitute in 7 for x. So 35 plus 3. So f of 7 is 38. And you're done. So this is how we evaluate piecewise functions. Identify your x and look for what domain does that fall in, and that's the function you're going to use. And then we're just substituting that value in for x. Alright, so I know we normally don't do evens, but I really want you guys to try this on your own. Alright, so you're given this g of x function, and there's three different functions in this piecewise function. Alright, identify the domain, and then look for which domain does the x fall in. Alright, so our first domain is when x is less than or equal to negative 4. Our second domain is when x is between -4 and 1, so when x is greater than -4 and less than 1. And our last domain is when x is greater than or equal to +1. All right, so identify which domain does your x fall in. That's the function you're going to use. Plug it in. All right, so give number 2 a try. Pause your video. When you come back, I'll have the answers written on your screen, and we will go through it together. So pause your video now. All right, so you should have gotten 25, 0, and 0. If you got those answers, you can go ahead and fast forward through this explanation and move on. If you didn't, then listen up as I go through these one by one. All right, so for part A, we're saying g of 2. Our x is 2, so we want to look at what domain this falls in. Is it less than or equal to -4? Is it between -4 and 1? Or is it greater than 1? Well, 2 is greater than 1, so this is the function we're going to use. Then we just plug 2 in for x. Remember, we have to do exponents first, so we do 2 to the 3rd power first, then multiply by 2, then add 9. All right, and that's how we get 25 for A. B, we're saying g of -1. So which domain does -1 fall in? Well, -1 would be in this domain here. It's between -4 and +1. So we're going to be using the function -x minus 1. We plug -1 in using parentheses. Remember, anytime we're saying minus a negative number, it's the same as positive. All right, so this turns into +1 minus 1, and that gives us 0 for B. And last but not least, C, g of -6, so x is -6. Which domain does that fall in? Well, that falls in x is less than or equal to -4. So this is the function we're going to be using. And then we just plug in -6 for x. But we end up with 1/2 times -6 gives you -3, add 3, and that's how we get 0 for C. All right, so if you have any questions on this, please raise your hand, call me over so I can help you. Otherwise, let's move on. All right, so now we're going to talk about how do we graph piecewise functions. So our goal is to graph each piecewise function, then identify the domain and the range. All right, so we're going to start with our piecewise function, and we're going to start with the first one. So the first part of our piecewise function is this right here. All right, so we're saying f of x equals x. When, or if, x is less than or equal to -3. Now, f of x equals x is the same thing as the equation of the line y equals x. All right, and y equals x is basically y equals 1x plus 0. This helps us because that means 0 is our y-intercept, so we know our graph's going to start right there. And then we know we're going to go up 1 over 1, right? Up 1 over 1. And we can go down 1 over 1, down 1 to the left 1, down 1 to the left 1. All right, and we can go in both directions here across the whole graph. That is the equation of that line. All right, now we're saying this is our line, y equals x, if x is less than or equal to -3. So what we want to do is look at our x-axis, and we're saying this is our line when x is less than or equal to -3. So from here to the left, when it's less than -3, this is our line. So we know we want this to be our line right here. And hopefully you guys have rulers. Use a ruler and draw a straight line with that, okay? So that is our line when x is less than or equal to -3. So basically what we're looking at is we want to say x is, our domain here changes at -3, right? We're saying this is the equation of the line when x is less than or equal to -3. This is our equation of the line when x is greater than -3. So -3 is when our domain changes, right there. All right, so we don't need all of these points because we only want the line when x is less than -3. So from here down. So what we do is we graph the equation of the line just like we did, and then you want to erase all these dots over here because we don't need them, okay? Now, we just graphed the first part of our piecewise. This is our piecewise function when x is less than or equal to -3. And because it's less than or equal to -3, we want a closed dot, all right? Now, second part of our piecewise function, we're saying when x is greater than 3, the equation of our line is negative 2x plus 1. All right, and this is the same thing as y equals negative 2x plus 1. And you should all be able to graph that on your line, right? So our starting point is 1, so we put a closed dot at 1, and our slope is negative 2. So we would go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. We can go up 2 and to the left 1, up 2 and to the left 1. All right, and now we know we want this equation of the line when x is greater than negative 3. So where our domain changes, once again, is at that line, x equals negative 3. And we would know we want this red one, we want this function when it's greater than negative 3. So that means we want an open circle wherever our line falls on negative 3, okay? Then we would just connect all of our dots using a ruler. I know that's terrible on here. Let's see if I can draw that a little straighter. All right, use a ruler and get a straight line with that, okay? But that would be our line when x is, we go to our negative 3, when it's greater than negative 3. So to the right of negative 3, that is our line. This is how we graph our piecewise function. And we didn't have to erase anything on this side because we just went up to negative 3 and we stopped, okay? If we would have kept going up over here, we would erase all the dots to the left of that line because we only want it to the right of the line when it's greater than negative 3. All right, and you don't need that yellow line, so you can go back and erase it. All right, we don't want that yellow line, so I'm doing my best here to erase it. That's just a little help for us so we know where does our domain change. When will our piecewise function change? All right, and that's how you graph it. Okay, that's our answer. Now we want to identify the domain and the range. So our domain, think left to right. So it goes, does it go to the left forever and to the right forever, and does it cover every value on the x-axis? We know this one goes to the left forever, and we know this one goes to the right forever. But if we're starting here to negative 3, now there's a closed dot and an open dot. If it was just an open dot, we could not include negative 3 as a value because it's not including negative 3. But because there's a closed dot here at negative 3, we can include negative 3. And then we know it goes to the right forever, so our domain is going to be all real numbers. Okay? Now, our range, we know it goes down forever because this arrow tells us down forever, this arrow tells us right forever and down, left and down, right and down. So we know it comes from negative infinity, but it stops right here, right? It doesn't go past here. It doesn't go up forever. It stops at this point, and that would be at y equals 3, 6, 7. So that would be at y equals 7. And now because it's an open dot, we cannot include y equals 7. So we would say that our range is from negative infinity, because we're coming from the bottom, all the way up until positive 7. And we use a parenthesis because we're not including positive 7 since there's an open circle there. All right, so number 5. Let's do number 5 together. So first thing we want to do is look at our piecewise function. All right, we know it's going to be this function if x is less than 2 and this function if x is greater than 2. So therefore, we know that our graph, our piecewise function, is going to change at x equals 2. So at this line right here, that is when our piecewise function will change. So to the left of it will be one value, and to the left of it will be this function, and to the right of that line will be this function, because we're saying when it's greater than 2, here's our graph. When it's less than 2, here's our graph. All right, so let's start with our first one. So when x is less than negative 2, or less than positive 2, this is going to be our function. And this is basically the equation of the line y equals negative 5 halves x minus 1. So we know that we want this equation of the line on our graph to the left of x equals 2 because we want it when x is less than 2. So we start by just graphing this line. We know our y-intercept is negative 1, so we put a dot at negative 1, And then to graph this, we want to look at our slope. So our slope is down 5 to the right 2. So down 5 and to the right 2. All right, and now we're going to end up on our line on x equals 2. And now we know that's where our domain changes. However, we want it when x is less than 2, not less than or equal to 2. So therefore, the dot we just drew, we have to make it an open circle because we're not including the value of 2 because it's just less than 2. All right, and then if we were to keep going, we would go down 5 and over 2. That would be over here. Then if we want to go in the other direction, we go up 5 and to the left 2. Up 5 and to the left 2. We know it's going to be over here, okay? Now, since we just want this line, when x is less than 2, we only want the points to the left of x equals 2. So we only want it to the left so we can erase this point right here. We don't need it, okay? We don't need that point. Now we want to connect our dots, and I did figure out how to get a line on here. So there we go. There is our graph. All right, so that is when x is less than 2. There's our line. All right, that's the first part of our piecewise function. Now the second part, when x is greater than 2, we want this line, this piece. So this is the line y equals x plus 2. So we know we're going to graph this just like we normally would. So we go to positive 2, put a dot, that's our y-intercept, and we're going to go up 1 over 1, up 1 over 1, all the way up. All right, and that's what our line's going to look like. However, we just want this line when x is greater than 2, so just to the right of x equals 2. We only want the value, this graph, when it's greater than 2, so to the right. So therefore, we're going to erase these two dots, and we have to do something to this dot right here. All right, because it's just x is greater than 2, this needs to be an open circle. So we're going to erase the ones that are to the left, and then we're going to rewrite that one as an open circle, okay? And then we're going to connect our dots and draw our line to the right. And there's our graph when x is greater than 2. We'll make sure we have our arrow because we know it's going on forever. All right, and then we can get rid of our green line, right, because we don't really need it. So we can get rid of that green one, maybe. I don't know if this will let me. All right, and then delete that green one. There we go. And or for you guys, just erase that line that you drew, all right, where you were marking where your domain changed. And now we have our piecewise graph. All right, when x is less than 2, it's the yellow one. When x is greater than 2, it's the blue one. All right, and we've got our two different pieces of our piecewise function. Now our domain. Domain, we look from left to right. We look at our x-axis. So it is our graph going to the left and right forever. This arrow tells us it's going to the left forever. This arrow tells us it's going to the right forever. However, when we get to x equals 2, we've got an open circle down here and an open circle up here. So neither of our graphs are including x equals 2. So therefore, we have to write our domain in a certain way because we're not including 2 in our domain. It skips over it both times because there's open circles. So how we would write that is we would say from negative infinity to 2, and we're not including 2, so we use a parenthesis, union, not including 2, so we use a parenthesis, to positive infinity. So what this basically means is that x does not equal 2, all right? When we write it like this, we're saying we're skipping over 2 because we're not including 2 on either side. But we're saying from negative infinity all the way up until 2, but not including 2, and then from 2, but not including 2, towards positive infinity. All right, so that's how we would write this domain. And then range, we want to look from bottom to top, look at our y-axis. It doesn't go towards negative infinity forever, right? These arrows tells us it's going up forever, but we know we're starting at this value right here, okay? If we were to draw our horizontal line where our graph's starting from the bottom, it would be right here, and that would be at y equals -5. We're not including y equals -5 because there's an open circle here. So we would say from -5 towards positive infinity. And you know what? Now that I'm looking at my graph, I think that's wrong. Hopefully you guys caught this, all right? But this circle right here should actually be, if we were to go down 5 and to the right 2, we would go down 5 and to the right 2. It would be at that point right there. All right, so I was off slightly. So that would actually be our point, and we need to change this line. Hopefully one of you guys caught this and told me already. All right, but if not, keeping you guys on your toes. So actually our range would be starting at -6, right? Because this would be y equals -6 towards positive infinity, okay? So our range would be not including -6 because it's an open circle, but toward positive infinity because it's going up forever. All right, so now what if you're given the graph and you want to be able to write the piecewise function? All right, so that's what we're going to practice in these next couple of examples. And I know it's kind of hard to see on your handout, so be sure to look on here to help you clarify where all the points are. All right, so example number 1. We're given 2 lines, all right, 2 pieces of our piecewise function, and we want to write the piecewise function that goes with this graph. So the first thing we want to do is identify where does the domain change, all right? What is the point where our graph splits, where it's 2 separate functions? And we would look at our x-axis because we're asking about where does the domain change, and that would be right here. So we know that our domain changes at x equals 1, all right? So what we're going to do is draw or highlight or something, highlight that line, all right? Because that's where our graph changes. So we know that the first part of our piecewise function, we're going to say that f of x equals something. We know it's going to be 2 separate pieces because we have 2 lines. So we're going to have something if x is less than -1, all right? And then we know we're going to have another part when x is greater than -1. So we know that's where it's going to split. So what we want to do is first look at the part that's less than -1. Which one is to the left of -1? And that would be our blue line right here. Now we want to be able to write an equation of the line for that. So in order to write an equation of the line, we need the slope and the y-intercept. So first thing we can do is we can tell what is the slope of this graph. So we know that we've got a point right here and a point right here, right? And we know that it's going down 3 and to the right 1. So therefore our slope is going to be -3 over 1. So our slope is going to be -3. And we know that's -3x. Now we want to identify where is the y-intercept, where does it cross the y-axis. So what we would want to do is just try to continue this line. So if we went down 3 and to the right 1, that would be our next point right there. Therefore, it crosses the y-axis at +1. So our b would be +1. Now we just wrote the equation of the line. So -3x plus 1. We identified our slope and our y-intercept. And when we're looking at this graph, at the blue one, right, we know that it was an open circle at where our domain changed, okay, at x equals -1. So therefore, this would just be less than -1 because it's not including -1, all right? And we're done with the first part. Now we want to look at when x is greater than -1. So to the right of -1 would be our red line right here. First thing we want to do is identify our slope. So we know we've got a point here and a point here. So therefore, we went up 2 and to the right 1. Up 2 and to the right 1. So our slope would be 2 over 1. 2 over 1. Therefore, our slope is just +2. So an equation of the line in slope-intercept form, y equals mx plus b, would be 2x. And where did it cross the y-axis? What is our b? Well, it crossed the y-axis at +3. So 2x plus 3. That's our equation of the red line. And then if we're looking at our graph, we know that, I wanted my eraser. There we go. Let's see if that'll work. All right. Well, I got rid of the highlight, but that's okay. We don't really need it anymore. All right, I'll just put it back so you can see. Okay, there we go. So we know that we want this equation on the line if x is greater than, so it's to the right of -1. And we know that this was a closed circle at -1. So therefore, we want to change this to including -1. So we say greater than or equal to -1 because we have a closed circle on our red line. All right, and now you just wrote the piecewise function that matches this graph, and you're done. All right, so I want you guys to try example number 2 and try to look at your graph and come up with a piecewise function that matches this graph, all right? So go ahead and do this one on your own. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so you should have gotten this piecewise function right here. The important thing to notice is where does our domain change, all right? Where does the function change at what domain? And we know that that's at x equals 1. That would be at this invisible line or this sort of line right there. We look to the left of that line and to the right of that line. So when x is less than 1 and when x is greater than 1. So first, when x is less than 1, what we want to do is look at the blue line. So what we do is identify our slope and our y-intercept. So our slope, we know we're going down 2 and to the right 1, down 2 and to the right 1. So our slope would be -2/1, or -2. And that's how we get -2x for our first part. Then plus our y-intercept plus b. We know it crosses the y-axis at +2. So that's how we get -2x plus 2 if x is less than 1. Now we're looking to the right of this line. We know it changes to the right as well when x is greater than 1. So we want to know what is our slope. Our slope is up 1 over 1, up 1 over 1. So our slope is just 1. So we could say 1x or just x, and then we want to identify our y-intercept. So we go, where does it cross the y-axis? Well, if we were to keep going down 1 to the left 1, down 1 to the left 1, we know it would cross the y-axis right here. So therefore, our y-intercept would be -3. And that's how we get x minus 3 if x is greater than 1. So to the right of that line, that would be our equation of the line for the part of the graph when x is greater than 1. All right? If you're still confused about this, please raise your hand, call me over so I can help you. Otherwise, let's move on to example number 3. All right, so our last two examples, example 3 and example 4, we're going to do together just because these are a little bit different and I really want to make sure you guys understand how to do these, all right? So example 3, we want to write our piecewise function for this graph. First thing we want to do is identify where does the graph change at what domain. So we know it's going to be right here the graph's going to change and right here. So we know that this is going to be at x equals -3 and x equals +3. So we know we're going to have 3 different parts of this graph, all right, because we've got 3 different lines here. So if we were to write our function for this, we would say f of x equals, and we're going to have 3 different parts. All right, the first part is going to be if x is less than -3. The second part is going to be if x is between -3 and +3. And the last part is going to be if x is greater than greater than +3. All right, so to the right. So there's the 3 different parts of our function. So to the left, in between, and to the right. Now we want equations of the line for each of these. So what we want to do is look at the part of the graph where it's less than -3. So we go to x equals -3. Which part is less than that? That would be this one right here. All right, and we know it's a horizontal line, so horizontal lines are always going to be y equals a number. So we go, where would this cross the y-axis? This would cross the y-axis at +2. So the equation of this line is y equals 2. So we would say that this one right here, all right, the equation of this line right here would be y equals 2 if x is less than, and because it's a closed dot, we want to say less than or equal to -3, all right, because that line has a closed dot. Now, the second part of our function would be this right here. Oops, I want my highlighter. That would be this part right here, okay? And it's also a horizontal line, and that's when x is between -3 and +3. This would be a horizontal line at y equals -1. So we would just say y equals -1 if x is between -3 and +3. And because those are both open circles, we just leave them as less than symbols. We don't change them to less than or equals. Last but not least, we want to look at the part where x is greater than +3. So we're looking at that part on top that I just highlighted in blue. So that's also a horizontal line, and that would cross our x-axis, or our y-axis, at +3. So the equation of this line is y equals 3. So we know it's going to be y equals 3 when x is greater than or to the right of that yellow line. So we would say y equals +3 if x is greater than or equal to +3 because it's a closed circle. All right, and you just wrote the piecewise function that represents example number 3. All right, now last but not least, example number 4. All right, I'm just going to scoot this over so that we have a little more space and so that we can see example number 4 a little bit better. All right, so the first thing we want to do is identify where does our domain change for this. So we know that the piecewise function is going to change right there and right there. All right, so we know that's at the first one. This one is going to be when x equals -2. This one is when x equals +1. So if we're writing our piecewise function, we say f of x when, we've got 3 different parts here, so if x is less than -2, if x is between -2 and +1, and if x is greater than +1. All right, I think I made our brace a little too big here. So we've got 3 different parts to this piecewise function. So first thing we want to do is look at the part when x is less than -2, so to the left of this line. That would be this one right here. So let's identify that. I'm going to highlight that one in red. So that is our line when x is less than -2. And what we need is we need the slope and we need the y-intercept. So first thing we want to do is try to identify the slope. We've got a point here and a point here, right? So we know we're going down 3 and to the right 2. So -3 would be our rise and our run would be 2. So therefore our slope would be -3/2. And we would say -3/2 x, and now we want to identify what is the y-intercept. So we know if we went down 3 and over 2, if we kept that line going, it would cross the y-axis at -1. So our y-intercept is -1. Now we want to go back and look at this line, at the red line. All right, I'm going to re-highlight this because I had to erase stuff. All right, so looking at this line right here, and we know this was where our domain changed, okay, we see that this is an open circle for this line. So therefore, we leave this as just x is less than -2 because we're not including -2 in this line. Now, second part of our piecewise function, we're looking at this part right here. So I'm going to highlight that one in blue. Oops, highlighter. That's the second part of our piecewise. And we know it's going to be an equation of the line. It's going to be linear, so we're going to write it in y equals mx plus b. And we want to identify the slope and the y-intercept. So our slope is just up 1 over 1, up 1 over 1, up 1 over 1. So our slope is just 1. So we can either write 1x or we can just write x. Then where does it cross the y-axis? Well, that would be at +1. So the equation of this line is x plus 1. Now, I want to be able to see this clearer. So I'm going to erase this, and we can see that this one is, this blue line right here that I'm highlighting, has both closed dots at both ends. So therefore, we're including -2 and +1. So we want to change this to, we want to change this to less than or equal to, less than or equal to, because we're including -2 and 1 in this domain. Last but not least, we want to look at when x is greater than positive 1 would be this line right here. So we go to where does our domain change? To the right would be this line right here, and that's going to be a horizontal line. So it's going to be y equals a number. And it's a horizontal line at y equals 3. So therefore, we would just say y equals 3 if x is greater than 1. And because it's an open circle, we just leave it as greater than 1. All right, and now we're done. So I know the video notes were a little bit long today, but piecewise functions are usually something that a lot of students struggle with, so I wanted to be sure to go through these really in depth with you and make sure you really understand these. If you still have questions about piecewise functions, please be sure to call me over so I can help you out. Otherwise, look to the board to see what to do next, and I hope that you guys have a great day.